Hey everyone, welcome back to URevitGUY. This is a compilation of all of our most popular videos all together in one sitting without all of the introductions and endings, so you can view them all at once. Hopefully this will be rewarding for you and enjoyable. Let us know in the comments if you like this and we'll post more. Thank you.
Instead of working in a floor plan normally, you would typically work in a ceiling plan for the ceiling to be created in. Because a floor plan is a horizontal slice through the three-dimensional Revit model looking down on the floor, a ceiling plan is a horizontal slice through the three-dimensional ceiling looking up at the ceiling. So that's why it's a two separate plan view areas. In this space, I'm going to go to the Architecture tab, Build Panel, choose the Ceiling tool, go to the Modify Place Ceiling tab where you have ceilings as automatic ceiling and sketched ceiling type. Choose automatic first. In the properties type selector drop down list, I have a couple of styles for 2x2 acoustical system and gypsum wallboard ceiling. I'm going to choose the 2x2 acoustical ceiling tile. In the properties below that, you have a height offset from level, currently set at 8 feet. This is the ceiling height. I'm going to set that to 9 feet. Come over here to this space. You can see the highlight of the room boundary. If I left click, that's going to create an automatic ceiling in that location, filling that area in. I can continue to place as many automatic ceilings as I want to, and I can adjust those later. Hit the X or escape key to cancel out of that tool, and notice that each ceiling has been created as an individual item. So each ceiling, even though you created at the same time, are all separated. Choosing this ceiling over here, I can actually select the grid tiles and physically move them around, vertically up and down, laterally left and right. I can also rotate those. And notice that it only affects that one system, not the others. They're all separate. You can also use the Align tool and align one of the grid tile lines to the wall. So I know that that wall line starts with a full ceiling tile, or I can start with a corner, and I know that this corner starts with a full grid tile, and you can mark that on your floor plan or your ceiling plan correctly. Going to the Architecture tab, Build Panel, Component tool, place component, type selector drop down list. In the project browser, I have nothing loaded right now. So I'll go in the properties drop down list. I have a 2x2 lamp type. There are different lamp numbers and voltages. Those will affect the final output of the electrical service, as well as the rendering of the space. If you're doing that, will impact the various lighting fixtures that you include, because the lighting source will actually emit a fairly accurate lighting presentation. So the lighting can impact your model successfully or significantly. I'm going to choose this 2x2 style here, and this is a ceiling hosted light fixture, which means it must be placed on an existing ceiling. So notice how I'm not hovered over the ceiling right now. It gives me a no symbol telling me I can't place that here. As I hover over the floor plan of the ceiling area, it shows a preview of that. When you're placing the light fixture on the ceiling, it cannot see the grid tiles, so don't even try to place them aligned to the ceiling tiles just yet. You have to place them on the ceiling first, hit the escape key to cancel out of that component tool, and then use the Align tool to align it in place. And then you can use a copy tool to arrange the layout of the ceiling appropriately. Add some recessed cans in here. Again, these are ceiling hosted as well, have to be placed on the ceiling before they can be located. And whatever layout you're looking for, place as many as that are needed. And these also come in 12 bys and 24 by segments. I'm going to use a supply, place that back here. Again, these cannot see the grid tiles, so you have to place them first and then align them. And that can lay out the ceiling in this form. What's really nice about the ceiling fixtures is if you adjust the ceiling grid tiles, all the components can move with it because they're attached to the ceiling. Even if you rotate the ceiling grid, they'll follow that format. So if you recall from using AutoCAD, how many times you had to relay out a ceiling tile by copying and offsetting, you don't have to do that anymore, which I really appreciate. And once again, each ceiling system is separate, so you can adjust each one individually with different components, different fixtures. If you wanted to change these ceilings to a gypsum board ceiling, you can do that as well. Without replacing it, you can change the type style. And very similar to the walls and floors, you can edit the structure of the ceiling by editing its type properties. This is made up of a gypsum wallboard of 5/8 of an inch, and then a metal stud layer of 3 5/8 inch thickness for a total of 4 1/4. And you can move that up and down the list, changing its orientation. For the ceiling, the bottom of the list is the finished face, the top is the typical structural area. I'm going to change the gypsum wallboard material to show a frit pattern of the graphic, as it's currently blank or unable to be seen right now. So under the drafting pattern types, I'll change that to include a gypsum plaster patch pattern. And then when I click finish, you can see that gypsum board ceiling show up here, and I can change that in each of these spaces if they want to be a hard ceiling. Create a ceiling. I'll need to use the sketched base type instead because I'm not covering a whole ceiling area. Use a rectangle option, start that back here, and set the ceiling height correctly. So that's currently at a 9-foot ceiling height with a 2x2 ceiling grid. Green check mark to finish, creating that location. Create a ceiling also, again, with sketch base ceiling, and then using a gypsum board ceiling type at a lower height condition. I'll say it's 8, and then draw that in front of that area, say up to here. Click the green check mark to finish. Now I have 2 separate ceilings across this location. Cutting a section through that area, I see 2 different ceilings at different heights. This is the acoustical ceiling tile at 9 foot. This is the lower drop ceiling at 8 foot. So I'd want to cover that vertical gap distance in some form. And there just happens to not be a flooring on this level. One moment, copy your floor up to level 2. So this would be the floor deck of level 2. So you may bring a soffit wall up to that height. Go back to the ceiling plan, choosing the wall tool. In the properties type selector drop-down list, there happens to be a soffit wall type. Click on that. If I look at the properties of the edit type and structure, this wall happens to be gypsum board on a single finished face side of, in this case, the interior side, where the other side is a metal furring strip of 1.5 inches. If that's required to be thicker for structural purposes, you can change that obviously, but it's important to note that the gypsum board is on the interior side of this wall type. We're going to place that starting from level 1 at 8 feet off the finished floor as a base offset. So that's going to place it at the lower edge of the soffit that we're creating. As we place that, we're going to draw a line, location line to finished face interior, and then make sure that that's being added on top of the lower ceiling area. If you hit the space bar and flip to the other side, that's wrong. Make sure it's over top of the lower ceiling location and wrap that around. Then go back to the section cut, and I can see now that there is a vertical wall covering that gap between those 2 spaces, and it's currently going up to the deck above. Then you can drag the top of that down just to the underside of the deck, or whatever gap needs to be here for whatever purposes. You can do that as well. Those are also adjusting the height of the wall set offset from floor. Currently it's -1.75 foot, just based on what this floor structure is made up of. And there's a couple of options that you can use to clean this up. One is to go to the Modify tab, Geometry panel, and choose Join Geometry, and select the ceiling, and then the wall, and then the ceiling, and then the wall, and the ceiling, and the wall. And it joins all of that material together, which kind of makes it look cohesive and cleaned up, but I don't like that look. Instead, what I would typically do is I'll change it from a coarse detail level to a medium detail level, and now you can see that the gypsum board and the gypsum line on the soffits are visible, and they don't really line up right now. So I want to clean that up a little bit more. To do this, I'm going to select this wall, and I need to disconnect it by unjoining. So go back to Join and choose Unjoin Geometry, selecting the wall and the ceiling again on both sides. And now I'm going to drag that at least for the wall to be right above the gypsum board line for the soffit. There's still a line that crosses here. We'll fix that in a second. Same thing, drag that up here. So that's at least a better graphical connection for that construction. There's still a line again that comes across here. There's a couple of ways to resolve that. Turning the thin lines option on, you can see that's very thick lines. So I'm going to change the detail to something thinner, 1.5 inch equals a foot, and I can still see a line that comes across here. To correct that, I'm going to go to the Modify tab, View panel, and choose this option called Line Work. The Line Work tool, or LW, is a shortcut key for that. When I click on this, it allows me to change any line work to a different line style. So right now, whatever line thickness, weight these are, I can change them to a different line weight. And in this list, there's a wide line, thin line. We'll cover this a little bit later in drafting details. Right now, there's an option called Invisible Line. When I click on Invisible Line, I can select this line for the vertical of the soffit, so the horizontal of the soffit, and it makes that line disappear. Well, that helps, but I still need a line there to show that structure. But I can draw a line back over it using a different tool called a drafting line with a similar line style that joins across here and then stops the position where I wanted it to. So that looks a little more accurate. So there's some work that might need to be put into this view to make it look more complete, and no view is stuck with whatever the view looks like. You can always use different adjustment options to make it look different or better, or the way you want to see it. As well as on the inside, maybe this wall doesn't go out all the way up to deck on the inside of the soffit. Maybe you want to drag the top of that down here to just at the ceiling height or above that slightly. Maybe you want to add some batting on the top of the ceiling for heat loss or even sound penetration. So whatever your design calls for here, you may need to add a structural kicker between this wall and the side of the wall over here, or the side of the wall next to it. Again, everything is completely dependent on the design you're working with, but this now indicates a drop soffit connection between that room space and the two ceilings. In this master bedroom ceiling plan view, we'll be creating a trade ceiling condition, going to the Architecture tab, Build Panel, choosing the Ceiling tool, and a gypsum hardboard ceiling. We'll be starting by placing an automatic ceiling within this room at a 9-foot ceiling height using gypsum wallboard, at least to start the ceiling out, and then we'll adjust it later. Selecting this new ceiling, choose Edit Boundary, and I'll create an inset trade ceiling space, creating a rectangle with an offset of 4 feet, and insetting that within the space. Creating an offset of 2 feet, setting that within the space, and left click. So now I have an interior rectangle and the exterior rectangle. That's going to generate a 9-foot ceiling space. Inside of that, I'll create a trade ceiling location. Ceiling tool again. Now I use a sketch-based ceiling type with a rectangle, still gypsum board ceiling at a 10-foot height. So it's a 1-foot raised ceiling. I'm also going to inset this by 1 foot. So the 10-foot ceiling only exists right here at the moment. Click the green check mark to finish. When I look at this in section, I'll see, of course, that there are 2 different ceilings at different heights, but there's a gap between these 2. In this case, I'm actually going to use a slope ceiling condition, which is a little more complex. With this condition, I need to create 4 different ceilings that actually slant up to that ceiling height on all 4 sides. Choosing sketch-based ceiling, basically drawing a trapezoid shape at each edge, and then in the draw panel using a slope arrow, drawing a line from left to right on this side where the arrow is facing up towards the higher ceiling. Select the slope arrow, and it says that height offset at tail end, change that to 0 feet. Height offset at head end, I'll change that to 1 foot. That says it's going to slope up 1 foot across that distance. Click finish. You can see a ceiling show up here. Go back to the section cut and set that too high. You have to set that back down to 9 feet. Dropping that down to the correct height. So you can see how it's going to slope up to create that condition. Repeating that on all 4 sides. Looking at this room section across the entire span, you can now see that the ceiling jumps up at a taper, comes back down the other side. Where all 4 of these ceiling elements are separate. And then jumping to a sectioned 3D view of this same space, you can see how the trade ceiling is shown here. Again, tapers up on all 4 sides, and you can see the top of that from above as well. In this section, we'll look at preparing a ceiling in the living room area of this house by going to the 3D view to set up this environment. Go to the properties area, scroll down to section box, turning that on. Turns on the section cut box, where I can then bring that section box into the building. And I can see one side and then the other side of the building. And the living room space is here. We'll be adding a vaulted ceiling into this space. Since the ceiling needs to be sloped in 2 directions, that is not capable in the actual ceiling tool, since you can only add a slope arrow in 1 direction. One option is to go to the Architecture tab, Build Panel, Component drop-down list, and choose Model in Place. This is called an in-place model or an in-place family. You can choose different types of categories of objects to apply to this family. Different than creating your own Revit family, you can actually apply what are called system families for walls, floors, roofs, and ceilings. So in this case, we want to choose a ceiling to create that with. Click OK, give it a name, and then click OK. Now we're in a different orientation of the Revit software. We are in place family editor. If you're familiar with creating Revit families, this is the exact same tool as the Revit Family Editor, where you have all the normal tools at your disposal within a project, allowing you to design a family directly in the model, in situation. The big difference between an in-place family and a regular component family, you cannot get a family that is an in-place family out of the Revit model project and load it into another project. It has to only exist in the one project that you created in, and it can't be output to an external family file like a normal family. So because that is a limitation, it is best not to use this method unless you have no other source of action. Going to the Create tab, Forms panel, I'll choose a extrusion. First, I'm going to set the work plane of this view by going to the work plane panel and choose Show. Right now the work plane is on the floor, and I actually want it to be against this back wall. Changing that, go into the work plane panel and choose Set Work Plane. In this dialog box, you have different options. I'm going to choose Pick a Work Plane, which allows you to select a surface. When I pick this back wall, it changes the orientation of that blue field, which I can expand and confirm that that is actually on the right surface. So as I expand around, I can clearly see that that is on that back wall's surface. Go to a straight on view, and I can actually turn that work plane off from showing any further. Go to the Modify Create Extrusion tab. In the Draw panel, I'm going to use the pick line to select this ceiling line, and then this ceiling line, and this wall, and this wall. Join those two together by trim and extend a corner, and then offset whatever distance that you want the ceiling thickness to be. So that depends on how much material you need to include in the ceiling structure. For demonstration, I'm going to add a 1 inch thick offset. I'm going to zoom in closely so I can see this better. Make sure that you're offsetting that towards the inside of the room, and then I will join those corners together. Now I've created a ceiling thickness that follows the profile of the ceiling I want to create. Using this method, you can create as complex of a ceiling as you want to, with different undulations, different contours. In the extrusion type, it has to be a continuous extension. If there's any other contours, then it would make it more complex. But at least right now, this will work. Set the extrusion start to 0, extrusion end to 10 feet, and I can adjust that in a moment. Click the green check mark to finish, and as I tilt up, you can see that there is now a vaulted ceiling within that space. And if I click on it, looking at the properties window, below where the type properties would be, it says ceilings. That's the category name. So what that means is that you can actually add ceiling fixtures and family components that are ceiling hosted onto that environment. That's extremely important to allow this to help in your building construction. Now this also has grips on there that you can extend the roof condition, or sorry, the ceiling condition. And because I cannot see the exterior wall currently, I'm going to need to adjust the view slightly. When you are finished editing the ceiling of the in-place family, choose Finish Model, which closes the in-place family editor, taking you back to the normal drawing window. I'm going to extend this section box outside the building, and that'll pull the front face in further so I can see into that room. So now I can see the surface, and I can also see that vaulted ceiling space. What I need to do is extend that into the wall behind back here. You have to edit. Does it let me? Yes, it does. Okay. In this case, the family allowed me to extend this further. Make sure that you're selecting the right surface. In a 3D view, it can be very disorienting. In fact, let me change the view type to be hidden line. Maybe this will be easier to see. So as I'm using the Align tool, I'm making sure to select that front face of the wall, and then I pick the front edge of the vaulted ceiling, and then extends it to meet those two spaces. Now I've created a vaulted ceiling between those two locations. Also, from this same 3D design model for the in-place family, you can take the same vaulted ceiling design and turn it into other ceiling configurations. Selecting the extrusion, choose Edit Extrusion, and you can change them to any condition type that you want. Creating a arc shape for a vaulted ceiling condition is also available. Copy the same design down 1 inch and make sure that all of the edges line up correctly. And when finishing again and finish the final model, you can tilt up and see the barreled ceiling condition.
On the left side, you can see a number of completed roof designs that were generated beforehand. If we look at that in a 3D view, you can see that each of those have different roof connections and conditions. We'll create the majority of these over here. So these are all just one level wall outlines that will add a roof on top of each one at level 2 height. Go to the Architecture tab, Build Panel, Roof drop-down list, and choose Roof by Footprint. It will always ask you which level you want to associate the roof height with. You'll choose the most appropriate level height. So I'm going to choose level 2, click yes, and then it opens up your Modified Create Roof by Footprint tab where you have all of your normal draw tools, and you'll use boundary line outlines to generate the roof profile. You also have a slope arrow that you can use to generate other conditions that we'll look at. I'm going to use the rectangle tool at this point and then go into the options bar below, and you have choices for define slope, which is a checkbox on and off, an offset distance, and a radial angle at each. In the properties drop down list, I have a couple of options in this project for different choices. We'll look at the design of that in a moment. I'm going to leave it as this 12-inch thickness, and the base level height is currently level 2, and I'm going to set a base offset from level actually to -2 feet. I'll show you what that means in a moment. Then I'm going to come over to this roof condition and then draw a rectangle from corner to corner, and then click the green check mark to finish and tilt up 3D. So what that does is it creates a flat roof condition, and because I've inset the roof inside of the walls and dropped it below the wall height, it's creating a parapet condition where the roof is lower and the walls extrude up above that, creating a parapet height above that condition. So this is a very useful roof type, primarily for commercial and industrial conditions. The next roof types we look at are usually more affiliated with single-family and multifamily residential condition, but any types can be used in any location depending on your design need. Next, we'll look at this hipped roof design, which is just a 4-way hipped roof condition where all of these slopes are the exact same size. Top-down view. Back to the roof tool and choose Roof by Footprint, level 2. I'm going to change the roof properties to a wood rafter 8-inch on asphalt shingle insulated design, and the height of the roof, keep it level 2 with an offset of 0. Then in the draw panel, I'm going to use a different tool, which is called the Pick Walls tool. If you already have walls designed when you're creating roofs, this is usually a good method to do so. Pick Walls tool. And in the options bar, you have a choice where it says Define Slope. We're going to turn that on now. And then you also have an overhang number. And that is different only when you're using the Pick Walls tool. If I switch to any other tool, such as the Pick Line tool, notice that it now says Offset. All of the other tools also say Offset, unless you're using the Pick Wall tool. It makes sense of why it's doing it, but it's confusing that it just changes the naming condition in this one tool only because attached to the wall. What this is actually doing is as you use the Pick Wall tool and you pick the wall, it's going to create an overhang of the roof, which is still just an offset away from the line that you're selecting. So the difference between offset and overhang is very minuscule. It's just a difference between the offset distance for the edge of the roof compared to the line that you're selecting. In this case, at the wall. So I'm going to left click and place that on all 4 sides, and those join together at all 4 corners. And you'll notice that each sketch line also includes a little triangle symbol, which is a traditional slope angle definition. When I click on that, it says 9 inches over 12 inches. That's the rise and run ratio of the roof slope. So it's a 9 and 12 pitch on this sketch line, and it's actually the same in all 4 of these. So they're all 9 and 12 pitch slopes. You can change each one. We'll look at that in a minute. You can also see that slope in the properties where you can adjust it as well. And you can also see the overhang and a few other properties that you can adjust. At all times when you're using the roof creation tool, you must finish by using the green checkbox to click on that. And then when I tilt up, now a 4-way pitched roof, and I'm using asphalt shingles, so it gives you that shingled texture design, and each one of those slopes are in the same condition all the way around. After you generate the roof, when you select it, you actually do get a grip where you can move this grip up and down. You're actually changing the roof slope as you do so. Look at the properties of the roof now. It says, It's not showing me right now. But if I double click on the roof to edit the roof again, you'll now see that the roof slope says 5.5 inch by 12 inch pitch. 9, 12, 5.5 inch by 12, and 9 and 12. So as you're moving that grip, the roof slope is actually changing, making them even, at least on the same sides. Next, we'll look at a mansard roof, which is a roof on top of another roof that have different height conditions. And it involves a little bit more complexity, so we'll look at that. Starting the roof tool again. Again, level 2 height. I'm going to use a rectangle tool with an offset of 1 foot now. Again, that is pretty much the same option as using the overhang of 1 foot by picking the walls. Again, each one of these roof sketch lines are defined as a 9 and 12 pitch slope. Now I'm going to use another rectangle tool with an offset of 8 feet, and I'm going to pick that along the interior face of the roof by hitting the spacebar to flip it towards the interior side. And I'm actually going to remove the sloping pitch for each of the interior sketch lines. So there should be a hole or opening within that roof design at the top. When I click on that and tilt up, the roof will actually show an opening or a hole in that space. And we'll add another roof location on top of that. But as you'll see, it's kind of difficult to set the height correctly. Choose roof again to level 2, roof pitch, within that same opening of the rectangle, and then click the green check mark to finish and tilt up. And as you can see, the roof inside of the other roof is actually lower than the one next to it. So we need to adjust that, and one way to do so is to change the base height so that it's actually above the roof so we can select it more easily. So I'm going to set that to 10 feet. Now that I can see the edge of the roof, I'm going to use the Align tool under the Modify tab, Modify panel, Align tool. AL is a shortcut key for that. And I use that by hovering over this lower roof section, and I need to hit the tab key a number of times until I get only a single line for the top line of the upper roof section for the start of the alignment. Left click, and then do the same thing with the upper roof above, making sure to select the top line of the, again, make sure I get a single line there, and left click, and then it joins those two roof segments together. Right now, they both actually have the same slope, so they're exactly the same height condition. But what I can do is change the slope of this so it changes the ratio between them, and it gives you that difference in the roof height so that you can adjust them individually. In some cases you may actually need to realign outline, but some of the compound roof conditions do require some additional roof design included. It does not have very complex tools that will let you create very complex roof conditions without some extra modifications of the roof design. Next, we'll create a single shed roof, which is just a one-dimensional roof slope going from one side to the other, which you can do in two methods actually. I'll show you both. Again, rectangle, offset of 1 foot from the outside. Make sure that all of the sketch lines are actually not defining a slope, and then pick one of them and then set that to define slope. And I can change that slope to, I'm going to go with a 2 and 12 pitch, so it's not too extreme. And then click the green check mark to finish and tilt up. And you can see that that roof is now sloping up to that point. What you'll also notice is that the walls are lower than that position. The walls do not automatically align themselves to the roof unless you tell them to. The way to do that is you have to select each wall segment, picking that wall. If I use the drag symbol and drag it above that roof layer, it does not automatically cut the wall off where it meets the roof. Instead, you must use a different tool. Select the wall first, go to the Modify tab and choose the Modify Wall panel where you see Attach Top or Base. Select that option and then choose the roof, and it will bring that wall up to meet that position. You must do that with each wall section to the same roof. So choose more than one wall if you need to, and then attach that wall to the roof. Now, each of those walls are attached to that same roof height. What's also nice about this is I can change the roof slope and the walls will automatically conform to that roof height because they're attached at those positions. I'm going to edit the footprint of the roof again. Go back to a top-down view. I'm going to select this sketch line and remove the option where it says Define Slope. So now it would actually equal a flat roof if I finish this. But I want to continue, so I'm going to edit the roof again. And going to the Modify tab, Draw panel, I'm going to choose the Slope Arrow option. And then I draw an arrow of either a straight line or a pick line. That's your only two choices I'm going to draw a line all the way across the roof from one side to the other. And then I pick the arrow, and in the properties I see some information. It says height offset at tail end is 0 feet, and height offset at head end is currently 10 feet. I'm going to change that to 4 feet tall. So that sets the incline slope of that roof from one end to the other. So it's going to start at 0 feet and go up to 4 feet total at the top. Click the green check mark to finish and tilt up. And I can clearly see how that roof is sloping up to that point. So that means that this top left height is at 4 feet above level 2. And this portion down here is at 0 feet from level 2. So that's how that roof height is set. To discuss this further, I'm going to first go into this model. And I'm going to set a option in the floor plan and go to the Architecture tab, Work Plane panel, and choose Reference Plane. And then I'll draw a reference plane along the front face of this wall here. And I can left click on the line and actually name this line, giving it a parameter name called wall face. Going up to the work plane panel once more, I turn on this show option where it says show work plane. And it turns on this blue background showing where the work plane is currently. As I zoom in here, I can see that that work plane is actually on the top of footing level. And I'm actually going to apply a roof by extrusion on the face of this wall. So I need to tell Revit which surface I want to work on. To do that, I go back to the work plane panel and I choose set work plane, and which opens a dialog box that says current work plane equals level top of footing. So that was correct. And I can go to the specify a new work plane option and go to the named section where I have a drop down list with different options. I can choose any grid line, any level, or any reference plane. And I have that wall face reference plane I just created. I'm going to choose the wall face reference plane, click OK, and that changes the orientation of the work plane to now be a vertical surface along the face of that wall. And as I orbit around the building, I can clearly see that that face is on the surface of that wall. I can actually contract that blue area. Again, as I zoom in and move around, it's clearly on the face of that wall. The blue area is not actually the extent of the plane, it's just a representation of the surface that you're working on. That surface plane actually goes on to infinity in all four directions. It's just representing where it is currently. And I'm going to go back to the work plane panel and turn off the show option. Then I will use the roof by extrusion tool by going to a front on face view, Architecture tab, build panel, roof drop down list, and now choose roof by extrusion instead of by footprint. Then it asks you what level you want to associate that with. I have more levels here, so I'm going to choose this parapet level height with 0 offset and click OK to continue. And in the draw panel, you have all of your normal draw tools. I'm going to use an arced line and draw an arc from, and actually this is one of the rare instances in Revit where you do not want to create a closed looped condition within the sketch. This is going to define the profile of the roof by extrusion that you're creating. So this is the extent of what you want the roof to be. And before I finish this, go to the properties window and I can choose the extrusion start and extrusion end. And from experience, I want to set that to 5 foot start condition and -5 foot, and click the green check mark to finish. And as I tilt up, I can see that the roof is now extruded outside of the building 5 feet and then into the building 5 feet from the face of the wall. What you'll also notice is there's a portion of the roof that is entering the building here. This could be going into a habitable space. That's not something that you want, where typically the roof is just surfaced on the face of the wall as an attachment. To keep that from happening, when I click on the roof, there's an option in the Modify tab that is called Openings Vertical Opening. So I will apply a vertical opening to that roof, which will cut off a portion of that roof. Before I do so, I need to change the work plane again, because if I try that now and choose vertical surface, it gives me an error that says cannot use work plane because it's not a level. So I need to cancel that, go back to the work plane panel and choose set work plane, and choosing the name drop down list, I will change that back to any of the level heights. It actually doesn't matter. It just has to be a flat surface. So I'll choose level 1. And once again, if you choose show, it's going to be on a flat horizontal plane. Then I go to a top-down view, select that roof extrusion again, and and I see Modify Roofs, Vertical Opening. I choose that vertical opening tool. I'll draw a rectangle from the edge of the wall where the roof enters the building, covering over the roof area where it exists right now, and then left click, and then click the green checkbox to finish. And when I tilt up, you can see what's happened is that the roof has now been cut off where it enters, so it no longer extends into the wall. It gets cut off as it attaches to the exterior wall. It does not extend further. You have grips that you can use to extend the wall out from the building further. That can go on indefinitely as long as it's structurally sound. And if you move it into the building further, eventually it's going to go beyond where you place that vertical opening cut. So it's going to exceed that if you pull it further, and it's going to extend beyond where that opening is located. So it's actually just created a cut within that surface that you would need to it. So as long as you don't exceed that, it's going to cut the roof out where it enters the building, and it will wrap around the wall this way if that's necessary for your design. You can create as many of these different conditions as you want. You can also change and edit the profile of the roof at any time to be different designs. And you can change that as many times as you want to, creating some very complex conditions. We'll be employing the same situation with these walls to create this type of roof condition. Coming over here, I'm going to select this wall surface and actually isolate those walls by going to Temporary Hide and Isolate and Isolating Elements. I'm going to set the work plane. You have another option within the work plane panel. Instead of choosing a named work plane, you can choose Pick a Plane. Click on that and choose OK, and it lets you pick a surface. I'm going to pick the surface of this wall here. That becomes the new work plane. So when I click Show, it is clearly on that surface. Then I'll go to a straight on view, and I'll now choose the roof by extrusion, set to level 2 height, and I'm going to draw an arc from one side to the other at some radius, and then click the green checkbox to finish. And I note that it extends into the building slightly without an overhang, so I can actually select that, and I could offset that slightly, or you can extend the edge of the sketch line out further. But I'm actually going to offset that to the outside and tilt back up. I can see that the roof extrusion was created there. So I want to go to a top-down view and then change the extent of this to the end of the wall and a little bit more. I could be more precise about this, but not for example is not necessary. So now when I tilt up or look around, it looks like a barrel vault roof. Again, all of the walls are not automatically conditioning to the height of the roof. So I'm going to select all 4 walls and attached to roof, picking those, and now they're matched up to that height. Roof is extended over that wall. Will they be attached? Otherwise they'll drop down. Next, I'll select this section of walls and isolate those and set the work plane onto this surface, a straight on view by extrusion level 2. I'm also going to create some sketch lines in this, so I'll start in the very center line of this roof, or actually this wall, go up 10 feet, and I'll come over at some angle and then back down at another angle. And I'll extend slightly over more. And then I mirror this to the other side, so it creates a mandrel roof condition. I delete the center line, again, a single sketch line following this whole profile. Click the green checkbox to finish, tilt up to the top, and then use the extension to stretch the roof from one side to the other, and creates that roof type here. Kind of a barn roof, or again, you still have to select the walls at all times and attach them to the roof. And you can always edit the sketch of the roof by selecting the roof and edit profile. You can change the roof's profile design, and the walls will automatically follow that profile as more of a church or steeple type roof design. You can even make it inverted if you wish. You can make as many contoured conditions within that roof. A couple of ways to do that as well. Always have to remember to set your work plane back to a horizontal plane surface as you've changed it for other purposes. Roof by footprint, and I'll create a gable end on the front and back sides, and on the left and right side I'll change those to something different. So 6 and 12 on one side, 9 and 12 on the other. Click the green check mark to finish and tilt up, and it looks something like this. So it's 2A pitched roof where you have gable ends on both sides. So that's one method of doing this. And of course you can still select the roof and then change the height of the roof as well. Another one is to select the roof again, delete all of the slope design, and then using slope arrows you can actually employ more than one sloping arrow from one side to the other, where you have one side that is set up to, let's go with 4 feet on this side, and then up to 8 feet on the other side. And it will match up those roofs wherever that peak needs to exist, looking something like this. Even though that I move the arrows beyond where that peak is located, the height of the head end is going to dictate where the peak of that roof, controlled by the location of the arrows, it will extend indefinitely until it meets that appropriate height. Next, I'll create this connected valleyed roof condition where you have two roofs side by side, and you can actually join them together even though they were created separately. Again, that would be the standard roof layout design. Here. And on the back side, I'm going to turn off the slope so that it becomes a gable end on this side, and all the other three sides indicate a roof slope, and I can even change the slope to 6 and 12. So right now I have a lower roof design and a larger roof in the back. How do I join these roofs together? There's nothing to extend that as a grip or anything. Going back to the Modify tab, Geometry panel, Join Unjoin Roof tool, select that. Choose the back side of the smaller roof gable end, and then the larger edge of the roof face that you want to extend it to, and it will join those together to meet them, creating a natural valley between those two roofs. This is the best way to create two roof connections. It does, in fact, create a overframed roof condition. You could use the vertical opening condition to cut out the inside of that roof, but that is a way to create the roof conditions between the connections. Another type of design we'll look at is this multi-part roof condition where you have a bunch of different roofed scenarios and they're all joined together as a single roof condition, creating all of these complex contoured roof slopes that are usually difficult to create in other softwares. The same layout, roof by footprint. I'll use the pick wall tool once more with a 1 foot overhang, and then selecting each wall face creates a sloped offset to the outside. And click the green checkbox to finish, and it creates all of those roofs designed together where they're evened up and each of the peaks are aligned perfectly. There may be some additional design changes that are necessary. You can even change the individual slopes separately. Some of them have different peaks that you can adjust. You cannot move the adjustments of the peaks where they exceed the slope height of another adjacent intersection. If it gives you an error, it may attempt to delete or remove the roof completely if it can't create it, but it gives you a lot of control over adjusting complexity of that roof design. Even something more complex, such as creating a arced condition, is capable as well. So if I have an arc here to there, and you can actually get curved roof conditions in here, provided all of the adjacent roof slopes are allowing that curve to exist. You cannot exceed the geometry that's available, but Revit will allow you to create complex geometry as long as it can create it. The last area we will touch on is adding a parapet roof condition to this building, and then adding a contoured roof design, which are slopes for drainage. To a top-down view, again, choose roof by footprint, draw panel using the pick walls tool, set the base height to the roof level, and make sure that you have no defined slope turned on, since this is a flat roof condition. And when you pick the wall, make sure that it's going to the inside of the wall. You can use this flip tool to flip it from inside to outside. That now gives you a currently flat roof design with a parapet wall above that. Then select the roof itself, and you'll go to the Modify Roofs tab, and you have a shape editing panel where you have the ability to add points, split lines, and then modify sub-elements. Choosing the Modify Sub-Elements will turn a separate sub-condition on where it turns all of the content behind what you've selected into a grayed out mode, and the roof that I've just selected now has a green dashed outline with green nodes at each vertex corner. Go to a top-down view, and I want to add split lines to various points and add individual points in the center of each section. And with each point and each line, you can actually change the elevation height for them. I'm going to change that relative to the current level, 5, so that's dropping it down 4 inches to create a roof drain slope 4 inches down from each peak. And And once you finish that, it will have created all of those three-dimensional contours for you. Now, after all of the contours are created, you can select the roof. And again, all of these slopes for the roof have been depressed along each section. The higher portions of the roof will become a cricket, and then the lower portions will become a portion for drainage. Next, we're going to talk more about roof materials. Selecting this roof here. Looking at the properties, there are a couple of options in the drop-down list, and then we'll go to the Edit Type Properties. The most important part about the type properties for the roof is the structure, and choosing Edit will open up the Edit Assembly dialog box. In the lower left-hand corner, choose Preview, and you can preview this roof in a section. On the right-hand side are all of the materials that make up this roof's construction. Layer 1 is a finished layer of asphalt shingle material of 1/4 inch thickness. Then there is a substrate layer of plywood sheathing of 5/8 inch thick. Then there is a structural wood joist rafter of 7.5 inches that you can define here. You can move the materials up and down the list, so I can move the rafter to the outside of the roof condition. The structural portion of the materials should always exist within this core boundary layer between currently layers 2 and 5. You can also insert new layers as needed. You can delete layers, and you can change their function from structure, substrate, thermal air layer, finish, or membrane layer. You can change the thickness to any thickness type that you want. You can also change the material. Choosing material, click this ... opens up the Revit Materials browser, and you have a very extensive list of materials that you can choose from. You can search for different materials. So you can search for something like, say, concrete, and you have concrete cast in place, precast concrete, and at the bottom, you also have this materials library that you can expand up, and you have another section called AEC materials. These materials are not currently loaded into your project, but are available to load from a pre-existing library of materials that get installed with the Revit software. So from here, you can choose different types of materials, such as terrazzo flooring. And if you like this material and you want to use it in your project, selecting that row and then choose this up arrow adds the material to your document. Then you can choose to use this material within any surface that you want, including walls, floors, roofs, and ceilings, creating different layers of structure, building up those material thicknesses as needed. The layer thicknesses, again, all add up to a total thickness height of currently 8 and 3/8 inches is the total thickness of this roof height. The top of the roof is the top of the roof height as according to the level height, and the bottom of the roof just lists underneath that at whatever the depth is set to. You can actually see this material when you go into an elevation or a section view. So if I go into a elevation view, this is a side elevation view of that roof on a building. So you can see the bottom of the rafter, the plywood sheathing, and the asphalt shingles on top of that. If you cut a section through that roof, you can see the same thing. So it actually does impart information into the materials that you're building for. And if you run a material takeoff, you can get accurate information of where all of the materials and square footage of these materials are existing. That also occurs within the wall construction. Finally, we will look at adding additional features on top of the existing roof areas, specifically on the edges, including a fascia and gutter. Going to the Architecture tab, Build Panel, Roof drop-down list, you have roof soffit, roof fascia, and roof gutter. I'm going to choose roof fascia initially. And then from the drop-down list, I have fascias of different sizes. I'm going to choose a 1x6 flat fascia, and then come over to this roof area and then click the top portion of the roof, and it places that fascia along that surface. Now the length or the height of the fascia will be dictated by the type of profile that you're using on that fascia. In this case, a 1x6. And simply selecting that material, you can use different drop-down list options. I can change it to a 1x8, 1x12, depending on what your needs are. Those can also have a material type applied to it. Right now I'm using a clad white material. I can change that to any material I want, including carpet or concrete. Just depends on what you want to use that for. Again, you can add the materials from below as well. The profiles are loaded from this area. You can load additional profiles from the Revit Families library, and you can define your own custom profile families. In addition, you can also add a gutter to the surface. This is a 5" by 5" gutter profile. Edit type, this also uses a gutter profile separate. You have all these different other sizes to choose from as well. I'm going to change the material. And just like with the fascia, you apply this by selecting the top of the fascia, and it adds the extrusion of the gutter around each face, very quickly adding an entire gutter system onto your roof construction. Lastly, we'll look at the soffit design, and to do that, I'm also going to use a hidden line view so I can see through to the wall locations. That will help me design the fascia locations. Roof drop-down list and choose soffit, not fascia. And I'll associate that with level 2. And you can choose your fascia thickness, soffit thickness. Also choose a white clad for that. And with this one, you actually build the extent in a plan view orientation of where you want the soffit to exist. Use the pick line tool, the pick wall tool, and define a 1 foot offset. And then remove the 1 foot offset and also apply another face along the surface of the wall. Drawing an interior line to define the other side of the soffit as well. This from the underside, you can see that it creates an underside soffit. That is the material that was just created along with the roof extension and overhang where it meets the wall to complete that box connection.
In this three-dimensional view, we'll look at navigating through the three-dimensional environment using various tools. In the upper right-hand corner is called the view cube. Clicking on this cube in different orientations, different corners, will rotate the image in any direction and orientation you wish. You can even look at the underside of the building. If there are structural, plumbing areas there, you can review those. You can see a direct straight-on view, clicking any of the 6 sides of this cube. Top, bottom, front, back, left, and right. You can also click on this home icon, which will typically take you to a top, front, right orientation. In this view are also the navigation bar, where you can click on this drop-down list where you have full navigation wheel and a few others. Clicking on full navigation wheel will bring up a navigation widget that will follow your cursor around, where you can zoom in by hovering over each text symbol, pan around, orbit freely. Rewind will take you back to a previous orientation. This is very useful because in a three-dimensional environment, it's very easy to get disoriented within your view and get lost or to an orientation that you're not happy with and it's hard to get back from. Next, we'll switch to creating a camera view, which is a panoramic orientation. I'm going to first go to a top-down floor plan view. This makes it much easier to create the three-dimensional camera view. Going back, View tab, Create Panel, 3D View drop-down list, and choose Camera. This turns your cursor into a camera icon. Wherever you left-click and place that first will become the placement position of that camera. I'm going to click on the outside lower left-hand corner of the building, and as you move your cursor, you can see where it's creating 3 horizontal lines, or 3 lines of length. These are the focal length in the middle and focal extent on the left and right-hand side. Left-click through the building to the other side, wherever you want to place that at an angle and direction, and that creates a new panoramic 3D view. You can see it's facing in the orientation and the direction where that camera was placed. Clicking on the outside boundary, using the crop box here, you can stretch that in all directions, widening that to more of a panoramic view condition. You can also change the view display style to wireframe, which is disorienting, hidden line, which is all black and white grayscale, shaded mode, giving the material coloring, which also has the shaded tone where the light source will be located. Consistent color gives everything the same color tone and feel. A new feature in Revit is called textures, which uses a form of the material rendering version. And then finally realistic, which is the full rendered version of the materials being used. This is a simplistic rendering. It will look even better than this when you run a full complete rendering of the design model. From this view, you can go back to the navigation wheel and use these tools to even greater degree. So you can use the zoom tool to zoom in and out of this space, pan around the view, orbit freely. Again, if you get into a situation where it's disorienting and you don't know how to get back to it, always use the rewind option to go back to a previous orientation. You also have the option to look up and down, from within this camera angled view. And my favorite part is the walk option. So you can actually move as if you're walking through the environment. The further away you get from that bottom dot, the faster you're walking. You can walk through environments. There's no stopping or clipping in this condition. Once you're inside, you can actually look up and down, seeing inside of this residential building. Again, you can see all of the materials being rendered there. Forward through this foyer area, look around further, kitchen area inside, walk towards the fireplace, turn around and look up, and you can see there's actually a balcony going to the second floor area above. Using the navigation wheel, you can also use the up and down option to go up and down. You can go down through the floor, up through the ceiling, and now that I'm on the second floor, I can actually walk forward, navigating around further. This is a great feature to use with clients to give them a free orientation of how looking in their building before construction can take place. This will answer a lot of questions, give them a better understanding of their design features, and hopefully give them a wow factor that will help them spec you as a consultant. Any one of these view orientations can be saved. So if you're interested in this three-dimensional view of the closet door, the view I'm currently looking at is under Views, 3D View, currently just called 3D View 1. I can right-click on that view, duplicate the view, and rename it to whatever I want. 3D Closet Door. Creating as many of these views as you want to. These can be placed on sheets, printed out for presentations. Definitely want to use those throughout the environment. Next, we'll look at the ability to create a three-dimensional walkthrough, which is a little more advanced feature using a similar function to the camera. Going back to the View tab, Create Panel. Going back to the View tab, Create Panel, 3D View drop-down list, and choose Walkthrough. Looks like a pair of feet. It says Create an animated 3D walkthrough of the model. You can export a walkthrough into an AVI file format or image files and export the walkthrough for later purposes. Click this option and it gives you the ability to select locations where you want the walkthrough to exist. You're actually placing camera positions with this orientation. So I'm just left clicking over and over again as I walk through this floor plan area. And when you're done with that, make sure you click the Finish Walkthrough option, and then that creates the walkthrough position. Looking in the project browser, this will also take you to a different area that has been added called Walkthroughs, which is a new category. Click into Walkthrough 1, which will take you to the view of the camera that you just created for this walkthrough. Again, using the crop boundary, you can stretch that out, change the graphics quality of the view. Once you have created the walkthrough and gone back to the walkthrough view, again under the View tab, Walkthroughs category, walkthrough number 1 is what this is called right now. Click into the view, it will show the last frame of the walkthrough that was just created. To access the walkthrough is a little confusing and difficult. Select the outside crop boundary of the walkthrough boundary of that view. Go to the Modify Parameters tab and choose Edit Walkthrough. This will actually open the walkthrough tools and allow you to edit and modify the walkthrough characteristics further. Now, by default, it will end with the last frame currently selected. Currently, you see where it's 300 of 300 frames, and there's no easy way to get the navigation tools of the walkthrough playback to show up. Instead, what you have to do is select the frame text area and then type in number 1 and hit enter. This will take you back to frame number 1 of the entire walkthrough. And in this case, it also exited the walkthrough edit. So you have to click the frame of the crop boundary again and choose Edit Walkthrough if that is what happened.
Then you can see where it says frame 1 of 300. So that is how many frames are currently existing within that walkthrough. Then you have a walkthrough bar that shows previous keyframe, previous frame, next keyframe, and play. When you hit play for the first time, it has to generate all of those frames individually. So where it says 300, that means once you hit play, it will have to go through and render all of those 300 frames for the first time, which can take a little bit of time. So you will have to wait for that to occur before you can see the entire walkthrough take place. I have already done this initially, so it's running a little bit faster right now, but you can see it's still slow. What it's actually doing is running through each frame one at a time, rendering that image out separately, and then you can stitch it all together as a video that you can export. Again, because of the intensity of this command, it is not easy to navigate the environment to make it look the way you want. It can take some time to get used to and get comfortable with the tools. When previewing the walkthrough, I highly recommend turning the view into a much less visual quality, such as from realistic, taking it down to hidden line. Then, when you preview the walkthrough, it does not take as long to render each frame. You can at least get an understanding of how the walkthrough is taking place. You can then navigate through the walkthrough frame by frame and actually save the orientation of the view that you're looking at by using the look tool to save that position within that keyframe. And then you can reset the frame back to the beginning again, and when you play the walkthrough video once more, it should capture all of those positions that you set the camera to. You can spend a lot of time working through this situation where you have all of the camera positions and angles set up correctly, all of the frames configured. And finally, once you have the entire walkthrough established, you can go back to the File Application menu, down to the Export tool, expand down and choose Animations and Images, choosing Walkthrough. It'll ask you some information on how you want that to be established. Here is where you definitely want to choose the visual style correctly. And depending on the visual style, the length of the video, and some other characteristics will determine how long it takes to export this video because of the time intensity of the rendering of each frame and video itself. And then you can finally use this video for presentation purposes. Once you have the walkthrough established, opening a floor plan view and the walkthrough view only, go back to the View tab, Windows panel, and choose Tile Views. You can tile both views side by side. Selecting the crop boundary of the walkthrough will actually turn on the camera path of the walkthrough on the floor plan. Then, as you edit the walkthrough and then play the walkthrough over again, you can actually see the camera translate throughout the building structure into each position where the camera takes place. You can see it turning and rotating, making its orientation to the final frame. From here as well, you can click on the floor plan and you have grips that will let you edit all of the positions of that camera in its orientation. Selecting the crop boundary of the walkthrough, choosing Edit Walkthrough, clicking back to the floor plan in the options bar below the keyframe walkthrough selection area, you have control options where you have active camera, path, add keyframe, and remove keyframe. Notice that all of the node grips of the path are red currently with active camera selected. Changing them to path option will switch them all to a blue node. Only when you are in controls path with the nodes being blue do you have the ability to select each camera frame and change its orientation and position. This is the only method that allows you to modify the camera after it's been created for the walkthrough. This gives you the ability to move and shift every position individually. You can then switch to each individual keyframe. Editing each one individually. Clicking on the option to add keyframe will allow you to add a new keyframe along the path and then switch back to path edit, giving the ability to control that new keyframe orientation. And again, it can be very difficult to get used to the controls within these tools. Also, giving the ability to remove keyframe allows you to select any of the nodes of the keyframes, removing those, or adding new ones again, or edit path once more. Switching between each frame by typing in the number. The controls absolutely could be a little more robust, but this is what it gives you for the option. Reset camera moves the camera target point back to its walk frame path if it has been adjusted from the original position. If that is not what you want to happen, then you'll have to reset that once more. Once all of the edits have taken place, again, it'll ask you to quit the editing of the walkthrough, click yes to keep the changes, select the walkthrough once more, go back to the first frame, and you can play the walkthrough once again with all of the edited changes. The speed of the walkthrough, at least in this condition, is not something that can easily be adjusted. Once the image or the rendering of the video has been exported, you can use third-party video editing software to slow down or speed up the camera itself. The tools within Revit are extremely limited, but that is not what the Revit software has been created for initially. It does give you the ability to create these images, renderings, and videos, but not all the tools necessary for editing them. This Revit model will be looking at placing a site layout on top of this residential home environment. Going to a view in the project browser. Under floor plans, I have a site plan already prepared, which is a top-down view with a set of reference lines for the outline of the site environment. In the ribbon, going to the Massing and Site tab, under the Model Site panel, choose Topo Solid from the drop-down list, and you have two options here. You can create it from an imported CAD file, or you can choose to sketch the outline. We'll choose Sketch. Go into the Modify Create Topo Solid Boundary tab. In the Draw panel, I'm going to create boundary lines using the Rectangle tool. From the outline corners of each of those reference planes, I'll create the outline shape here. Before finishing this, we'll look at a few options. You have a sloping arrow, which you can slope the entire grade all at once. In the Properties panel, you have a drop-down list where you can choose different types if available. You can set the level height
of the topography by default, any elevation heights, and other options. Click the green checkbox to finish, and I can see it shows up here as a gray surface. We'll adjust that next. Clicking on the Topo Solid, go into the Properties menu and choose Edit Type Properties. Opens a dialog box where you can either duplicate the styles, rename them, and modify their structure and other properties. I'm going to duplicate this type and create a name called Greenfield Site. And come down here. Under Graphics, you can choose what the object looks like in a coarse detail level. I can change the color of that to a green color if you want that to look like grass. And you can choose the contours of the grade to be displayed here with different options. I'll just leave that as default for right now. Under Structure, choose Edit next to that, and right now it's just using a by category material, which is non-specific. I'm going to insert a new layer of material and create a layer of grass that is 1 inch. And the remaining portion will be a variable size. The top layer, click Materials, and in the Revit Materials browser, I'll type in grass at the top to search. You can see grass option here, and you can see what that will look like by modifying the graphics, color, and appearance. You can change a lot of options there. Under Structure, click that surface, and I'll change that to Earth. And again, you have a couple of options with that as well. Currently a brownish color. The hatch pattern is using the earth fill pattern style automatically. Click OK and click OK again. And you can see immediately that that shows up as a green surface. Going to a 3D view, I can see where that surface already has taken place on top of the model. And as I zoom in here, I can see that I already have a sidewalk, concrete, and a driveway concrete layer that is just created as a flooring condition. I'm actually going to take the site model and drop it down, say 1/2 inch. Just to show some type of reveal between the concrete and the grass. That could be any height, it could be a total 4 inches, completely dependent on your design needs. Next, I'm going to click on the site topo surface, or topo solid, go to a top-down view orientation, and in the Modify Topo Solid tab, Shape Editing panel, you have some options. Under Modify Sub-Elements, you have a choice for Add Points, Add Split Lines, choose Modify Sub-Elements, and you can see the outline show up as a light green dash line with green points at each corner. This gives you the ability to add elevation changes to all of the site positions. This is how we will add elevation changes to the site design. I first want to create some split lines where the slope will take place at different points. Coming across the driveway here, and along the edge of this walk area. Next, I will add points to all of the edged corners of the outside structure of the home so that it keeps that as a flat plane when I modify the contours sloping up or down from that point. Now each of those points show up, and you can see as I select each of them, they already show the same elevation height as currently negative 1/2 inch. I can select all of the outside edges. I can select all the outside edges of the site and change those by clicking on the elevation number, the elevation height in the Modify Sub-Elements tab, or in the height offset from level in the properties. So all of those are the same option, and any adjustments will affect every location. I'll change that to -4 inches, and that will create the contouring from the residence down to the grade level. Let's in fact even make this a greater slope by saying it's a 1 foot drop. Currently, as I look at an on-side view of the building, I can tell that the concrete areas are still in the air because they are not sloping with the grade. Just like with the topo surface layout, when you pick on the concrete area of this sidewalk, it also has a shape editing panel, and you can choose to modify sub-elements here as well. Modify sub-elements, and you can also see where it creates the outline in the dashed green lines, and each point on the edges can be adjusted. I'll add a split line across this face here, where a break will occur after that point, sloping down to the next segment. I'll pick the bottom surfaces down here, and I'll set that to -11 inches to keep it 1 foot off the grade, or I'm sorry, 1 inch off the grade level. And as I tilt up, I can now see that that walk is grading or sloping down to the edge of the site. So just like with the topography surface, the concrete flooring surfaces have the same feature. I'll do this in each location. And now each of the surfaces are sloping down to the same point. You can take this to any degree of slope that you want. So for instance, if you wanted to have a raised mound in this area of the grass or site environment, simply select it and modify the elevation height of a certain area. You always have to make sure that you're isolating the surface with either a break line or split area. Even placing a single point in the middle of the space, you can see a relative elevation height as it's coming along the sloping grade. It's currently at this -4 inch and some change height. If I wanted to raise that, say, to 2 feet, it would just create a mounded surface up to that single point, in this case creating a pyramidal, and you can't even see all the contour lines show up. If for any reason you're ever unhappy with how the site layout is progressing and you want to start over, you can select the flooring or the topo surface, go to the Modify tab. In the Shape Editing panel, choose Reset Shape. It will remove any of the elevation changes and any of the sloping split lines and points, making it into a flat surface once again, where you can then start over from scratch. Any of the modifications that you make to the topo surface will continually update and modify the angular slope of the site overall. In the floor plan, go into the Edit Type Properties. I can change the Contour Display option to show contour lines. Let's go with every 4 inches. Looking at the site again, changing it back to a hidden line, I can see all of the contour lines that are showing up here, and I can change how many contour lines show at different elevation sections. Clicking on the topo surface, go to the Edit Type Properties. Under Contour Display, edit that and change the secondary contours to, let's go with every 2 inches. And you can see more topography lines show up, and you can even display interval lines at, say, every 6 inches, which show up as a slightly thicker line type. You can even go to the Masking and Site tab, Model Site panel, and choose Label Contours. This allows you to draw a straight line across the site displaying each elevation height across the contour lines. Simply adjust that line angle and it will change each point location where they're displayed. That elevation number will adjust immediately once the site elevation changes in any way. Obviously, a large area like this will show many contours. Lastly, you have a property line that you can add to the site as well. Go into the Massing and Site tab, Model Site panel, choose Property Line. You can choose this to be created as a distance and bearing, such as you would get from a site surveyor, or you can sketch the outline as well. Choose a sketched outline, create a rectangle shape around the reference plane outlines that we currently are using, and click the green check mark to finish, and that shows up as thickened property lines to continue developing your site layout plan. Creating groups. I have a full layout of spaces on this drawing. Each of these are actually the same exact size. That is not typical, but I'm going to show you the best case scenario for using groups at this time. All of these objects currently in this room space are separate elements of furniture and a few walls. Notice that this wall and this wall are separate from the other walls. That's going to be important, as these green walls are going to be included in the group. Select all of those objects, look at the filtering tool. Notice that I have doors, furniture, some lines for the outline, planter, which is that tree, some walls, and window. Click OK to continue. Now that I have those selected, looking at the Modify tab, Create panel, choose the Groups option for Create Group. GP is the shortcut key for that. Creates a group of elements for easy reuse. Similar to a block in AutoCAD. Click that, it asks for a name. I'll call it Office-1. It has Open in Group Editor. I'll leave that closed unchecked for right now. Click OK. Now, when I click on this object, it is now joined together as one element, or a group. That is the beauty of using groups. It joins things together that are not normally joined together with an object, to help them from separating and also to easily access them in different locations. Now that I have this group element created, I'm going to select the object. Notice that it says in Properties Model Group, Office-1, all selected as one object. In the Modify Model Groups tab, I have a Groups panel with options for Edit Group, Ungroup, or Link. Right now I'm going to select these and use a modifier tool as Mirror, and I will translate those all the way across this floor plan to every space. Now with a group created in each room space, they are all currently the same object. Watch what happens when I select one of the elements as a group, go to the Modify tab, and choose Edit Group. This opens the Group Editor location. The only difference is that you see it has a lighter yellowish background. The tab shows up that says Edit Group as a floating dialog box, and all of the content in this one group is now selectable and highlighted. Everything else is grayed out. From this dialog box, I can choose to add more objects to the group, remove any objects from the group, attach a detailed group element, finish the group changes, or cancel the group changes. Right now, I'm going to select these chairs, move them over slightly, select this window, make it a little bit smaller, and select this wall and move it out here closer to alignment with the chair. So a few small changes that I've made here. I'm going to zoom out slightly, pay attention to all of the other groups in this scene when I click this green check mark to finish. All of the groups immediately updated to the changes that I made to that one object. This is the power of groups, allowing you to affect multiple locations at the same time, provided those elements have been turned into groups before. This is a very widely used tool in the industry, especially for areas that are repetitive or of similar design. I've used this personally in elements such as schools, hospitals, elevator lobbies, anything that would be very consistent in a number of room spaces or from a floor-to-floor standpoint. Selecting this object here, look at the Properties menu, and you see where it says Model Group Office-1. I will click Edit Type, and you have a few options in here, but nothing that's really going to help me at this time. All I'm going to do is choose the Duplicate option and make a new group version that says Office-2. Click OK. Selecting that same group that says Office-2, choose Edit Group. Now I'm going to make some larger changes. I'm going to delete this tree. I'm going to add a component of a sofa, delete this wall, move it back in a little bit, rotate these chairs, and add another one in between. Rotate this desk set, move it against this corner,
of the wall. Rotate this desk set as a mirror opposite. So some wide changes that were made to that layout of the group. Click the green check mark to finish, and you'll notice that none of the other groups have modified to that design. Because I duplicated this type, it is now Office-2. These groups are Office-1. But I now have an option in the Properties drop-down list where I have Office-1, and I can change it to that design in any of these locations. Giving you this ability, you can make unlimited amounts of different versions of the same group. In each location, it could be changed. There is such a point where you can get to too many options of the same group. It might make sense to make it a different group or go a different way, but this is very useful in a number of different scenarios. With, again, tens, dozens of different types of designs, you can affect each one of those as either room types or room layouts. These kind of groups could be set up in a template file that you use on future projects for different room styles and types. If you have those set up in a list or catalog of rooms, this could be very helpful. Also, as I hover over any of these existing groups, I can hover over an object and hit the Tab key once, selecting this tree for instance. There's a little symbol up here that says Group Member. Click icon to exclude in this group instance. So that means if I left click and hit escape to cancel out of the group selection, that tree has disappeared from that group. I didn't just hide it, I've excluded it from that group location. So that means that is not going to be part of a material count or a takeoff cost, or it's not going to show up in a schedule. That location of that element has been removed from the project. Notice that that same tree is still in all of the other office groups. Now I can come back and add an individual element that is not part of a group. Maybe there's a single office desk chair in this corner, and that only affects that one location. So if you can utilize groups and still have one-off elements, that is another good use for the group objects. Edit this group again, duplicate. Maybe I can say there's a 1B, which is the similar version of Office 1, but a slight modification. So I can edit that group and say, okay, I want this chair to focus in towards the desk, move it back a little bit, move this chair facing that way, repeat the same location on both sides. And that's all the changes I've made. Click the green check mark to finish, and that is just one more version of options. Change that to Office 1B, and the chairs have been rotated that way. Again, you can make minute changes, monumental changes. I could make another version. Office empty. Edit the group, remove all of the objects in the group, click finish, and they're empty. And I could use this as an empty blank canvas to add individual content, or if I decide I want to come back to it, I still have that option. So it gives you a lot of flexibility. The reason that this is helpful to still have as a group, again, is the ability to switch to different existing group styles, and the fact that the door, walls, layout is still present in that group. It still serves a purpose. Another option you have is to convert a group from an interior local group object to an external linked file. So choosing this singular office of Office 1, I'm going to choose the converts the selected group to a linked file. Click that option. It'll ask you if you want to replace it with a new project file or replace it with an existing project file. The new project file saves the group that I currently have selected as a new project and removes the group instance and its locations and replaces them with a linked file to the project. So make sure this is the right choice that you want to take because it is not easily reversible. I'll choose new project. It's going to ask me where I want to place that. Located on the desktop here. And it is going to save it as a project RVT file. Okay. Now that I've done so, when I click on this office, notice that it changes to a RVT linked, and this is now a Revit linked. All of the other offices are still here as a grouped element. This one alone has been changed to a Revit linked file. So a good use for the linked file version of groups
is there could be some user working on the main bones and scaffolding and skeleton of the building. Someone else could be responsible for the layout or fit out of each individual room space. You could create multiple different room types and then load those into your projects as linked elements. Therefore, you could have separation of responsibility. You could have multiple people working in different locations, not on the same server or network location. You can have them as consultants that are working outside of the company. This provides a lot of extra flexibility that you cannot have using Revit with a live network server access requirement, unless you're using something like Autodesk BIM 360. With this linked file, it is now included as a Revit link, shown here, office1.rbt. Nope, sorry, group office1.rbt. It is loaded, it's listed as an underlay, the saved location would be there, and I can reload it, I can remove it, I can modify it to any degree that I wish. The only difference is that these other offices are now groups, and I can replace them with the one I just added. So I can click on this one and choose link again, and I can say, instead of replace with new project, I can replace it with an existing project file, and I choose that group office that I just created, and it replaces it with that one. Again, it removes the opportunity to be able to change it to a different type once you do so, but it's yet another amount of flexibility that you have in the tools. Going to another project, I have a layout here of multiple floor rooms of a hotel. Going into this hotel building, I'm on the second floor, selecting all of the objects in this one room. Make sure I filter out anything I don't want selected, including the demising wall. Click the filter tool. I have all of these objects selected. I'm going to turn those into a group as well. Click OK to continue. It's going to ask me to name this. I'll call it Guest Room 1. And notice there's another option that says Attach Detail Group. This will be important as well. I'm going to label this the same, Guest Room 1, and click OK. Notice that the room tag is not part of the group because it told me that it was excluding it, which is fine, that's correct. And all of this object is a group, Guest Room -1. I'm going to continue to replicate this group element across the floor plan here. Notice how the doors on the balcony and the front entry door are automatically cutting the walls that they're intersecting with. That is important and helpful. And that whole floor is now laid out. And you'll notice that the tags that were in this first space did not translate to all of the other rooms. How can I fix that? Selecting at least one group, go to the Modify tab, and I now have a new option that says Attach Detail Groups. Click that option, and the only option here is Guest Room 1. This is a detailed group. When you add annotation into a group, the annotation can only exist in the view that it's been added into, just like other default annotation. Because of the way that groups and annotation work in Revit, it doesn't create a group of the annotation included. It creates a separate sub-category called a annotate group. The main group that we've been talking about so far is called a model group. It can only hold model content. The detail group only can hold annotation, dimensions, tags, things like that. So they are separate, but they are connected. So I can select all of these other groups at the same time. They're labeled as model group categories, and then attach detail groups to each one of those all at once. It is using the appropriate tags for those objects. Each door has received a new door number. All of the tags are appropriate to that object, and if you change it in one location, it will affect everywhere. Now that I have all of these rooms laid out across this floor plan, I have levels 3 through 8 that are all the exact same size and have not been populated with room information. Because I have these rooms grouped and all of the floors above are exactly identical on a vertical height basis, I can very easily copy and paste these from a floor-to-floor standpoint. Then all of the floors in every room will include the same group object, so that if I change something once, it will affect the entire layout of the rooms in the building. Make sure I don't select anything unexpected. In fact, I actually only want
model groups. Go to the Modify tab, Clipboard panel, and choose Copy to Clipboard. Control-C is the same tool. And then you have a Paste drop-down list where I'm going to choose Paste aligned to selected levels. And then choose levels 3 through 8. It will think for a second. And then that will have transferred a copy of all of those members to each floor, where now floor 3 is laid out with the exact same conditions. Floor 6 is laid out as well. As long as everything is consistent, it's very easy to use the groups in this manner. When they are different, you will have to adjust the groups so that it doesn't incorporate the entire space. There could be extension of walls that go beyond the group's available length or extent, but you can still incorporate groups in that method. So I'm on floor 6, room 606 here. What if this room is slightly different? Again, I'm going to select to edit the type, duplicate that room, and I'll call it room 2. Select that group and choose edit group. Instead of a queen bed, 2 queen beds, what if there's 1 king bed? So I'll move this towards the center, use the properties drop down list, change this bed type to king, and immediately it changes that design. And maybe in this space there are 2 of this chair. Use the space bar to rotate that, and again click the green check mark to finish. So now I have a new style, and if I select all of those groups, model groups, attach detail group, and now each one of those rooms has been filtered with the same amount of annotated information. You will need to go to each floor plan, each view, and include the detail group separate. Again, because it's annotation, it only shows up in the one view where they're at. I would highly stress that if you are going to populate all floors in your building with the same multiple grouped layouts, make sure that you spend extra time verifying that the groups are as accurate as possible, because after you have copied these to multiple floors, it's going to exponentially take time to fix any errors that were made beforehand. So if you can catch those errors and make everything as correct as possible first, that will save a lot of time. Lastly, an option that you have is to select the group and choose ungroup. That removes it as being a grouped object, giving you the ability to independently make changes that will not affect the other groups. This is no longer a grouped element, so you would only use this in a one-off situation most likely. Maybe this is a single twin bed inside of an empty room, maybe the cheapest room in the hotel. But you can have as many of those different options as you want. They could remain as groups, or you could ungroup them. It does not affect the Revit model in any way as far as size or connection goes. The one caveat I will share is that any wall-hosted items that are attached to objects not in the group as walls, if there are walls that are not attached in the group is what I'm saying, the wall-hosted items cannot exist in the group because the wall is not part of the group. Such as this demising wall was not part of the groups that I created. If there was a wall-hosted object on this wall, it could not be included in the group because it would cause errors owing to the fact that the wall is not part of that group, so therefore the wall didn't exist where the object is located in the group. Wall-hosted object cannot exist without the walls they're attached to. This wall in the lavatory or restroom is included in the group, and you could have wall-hosted objects attached to that wall. I've worked with different companies, and I've used this myself, where you can either place a small fake wall at a very minuscule amount of thickness in the group just to represent a location of the wall. You can attach something to it, or you can create a family that is a non-hosted element. This comes into play mostly on wall-hung cabinets. If you are placing a wall-hung cabinet in a group and it is part of a wall that is not part of that group, it can cause issues, and you can either, again, treat it as a non-hosted family, or you can add a minuscule portion of a wall so you can attach to it. Both of those options include a little bit of extra work, because wall-hosted items are, by design, not unhostable, and you have to either recreate the family or find a location to download a resource that is.
Check out our previous videos below. Comment below and tell us more information you'd like to see covered in the Revit software.